Alright, so this is going to be another video where we're exploring the differences between base 10 and base 12 geometry. I said before that it lies in the dividing up of the 1. So to again give you another example, here we have a square that has the dimensions of 1 by 1. You can see that the coordinates of base 10 and base 12 of this point here are both 0, 1. So that means that the square of 1 by 1 is the same size in base 10 and base 12. It lands on the Cartesian plane exactly the same, but when we look inside the square, we can see that the lines that are formed, the black lines, which is base 12, and where they cross each other is different points than where the red lines, which are in base 10, are crossing each other. So these are the lattice points. They're called lattice points, where the horizontal and vertical lines are crossing each other. So that's what defines the size of the decimal places. So we have a line here going also across at a diagonal, the length of square root of 2. So again, from 0, 0 to 1, 1, that's the length of the square root of 2, but the individual units, 0.1, 0.3, 0.7, root 2, are going to be different lengths in base 10 or base 12. And to really illustrate that point, I got 2 sticks here. So first I'm going to put this red stick on the board, this length. We're going to go from this point here over to this point here. So if we count the squares, we're going at a diagonal of 45 degrees, so we're in units of square root of 2. Go 1, 2, 3, 4, 5. So this stick here is the length of 0.5 root 2 in base 10. So now we're going to do the same thing with this stick here. It's a black in base 12. So I'm going to go from this point here, putting the stick down again at a 45 degree angle, again units of square root of 2. And we're going to count again from here, 1, 2, 3, 4, 5 also. So this length is also 0.5 root 2, but this is the base 12 length. So we can see, we got 2 sticks. They're different lengths, one in base 10, one in base 12, and they're both the unit, or both the length of 0.5 root 2. So we can really see the difference that it makes in base 10 or base 12. It seems like it should be the same number. When we look at the diagram for the dodecagon, we just see it like this on the grid. It seems like it's a fixed length. It doesn't matter how we approach it, but we can see that it actually does. In terms of how it lines up with the 1, depends which base we approach this shape in. So we're going to be exploring the dodecagon further now in future videos, looking at its relationship to the circle in base 12 geometry, and eventually ending up at a base 12 version of pi. So I hope you can join me for those videos. Thanks for watching.